Hey everybody. Tonight we are going to talk a little bit more about how to work with fractions, and specifically we're going to talk about the idea of equivalent fractions. So it's important to understand what equivalent means, right? Equivalent, if two things are equivalent, it means that they're equal. So when we're talking about fractions, one useful way to think about them is to use models, right? We can use models. We have two models right here, and we can use models that are the same size. Notice how these rectangles are the same length, to compare fractions and decide if two fractions are equal or not, or if one is greater or if one is less than the other. So let's look at the fractions 2/3 and 4/6. So we have this rectangle here. We have two of the areas shaded in out of the three total areas. So our fraction here is 2/3. And our next fraction, our next model, we have four of those rectangles shaded in out of six total. So that fraction would be 4/6. And notice how our models here are the same size total and the same amount of area is shaded in. So even though our two fractions look different, 2/3 and 4/6 look different, the shaded area is exactly the same. So these are equivalent fractions. 2/3 is equal to 4/6. So that's the main idea behind equivalent fractions. They are fractions that, even though the numerators might be different and the denominators might be different, they name the same amount. And you can make equivalent fractions using one of two ways. The first way is you can multiply the numerator and denominator by the same number. So let's think about when we have 2/3. If I want to make 4/6, I can multiply the numerator by 2 and the denominator by 2, and I get 4/6, which we just saw on the previous page is equal to 2/3. You can also divide the numerator and denominator by the same number. So I could start with 4/6, and I could divide both of them by 2. And when I do that, 4 divided by 2 is 2, and 6 divided by 2 is 3. So we get the other fraction. So we see that whether we multiply or divide the numerator and denominator by the same number, we get equivalent fractions. We're going to work on 3 examples here to wrap up, just to get a little bit more practice of changing these fractions into different forms, but keeping them equivalent. So let's start with 1/4. With 1/4, I could multiply both the numerator and the denominator by 2. Times 2 equals 2/8. So that's my first equivalent fraction. We're going to do 3 for each. I could also do 1/4 times 5. And 4 times 5. I can really pick any number I want. 5/20. Still equivalent. I could even do a bigger number. I could do 1 times 10 and 4 times 10. And that's going to give me 10/40. So it doesn't matter what number we multiply by, we're going to keep getting equivalent fractions. Example B, we have 11/33. So 11/33, we can do the same thing. I'm going to multiply by 3 this time. I haven't used 3. We get 33/99, equivalent fraction. 11/33, we could multiply by 10 again. I like multiplying by 10 because all I have to do is add a 0 onto the number. So that's 110 and 330. And this one, I noticed that these two numbers actually have a common factor. So I can actually divide 11/33 by the same number. I can divide the numerator and denominator by 11. So 11 divided by 11 is 1. And 33 divided by 11 is 3. So we have another equivalent fraction right there. All of these fractions, 1, 2, 3, 4, all of these are equivalent, just like all of these are equivalent. And our final example, example C, we got 5/25. Now I notice right away that I have a common factor here, and it's 5 because both of these numbers end in a 5. So I'm going to divide both of these by 5. And 5 divided by 5 is 1. 25 divided by 5 is 5. Now what I can also do is I can take my new equivalent fraction, because I know this one is equal to this one. I can use this fraction, because this is equal to this. If I change this, my new fraction will still be equal to the original one. So I can use 1 over 5, and I can multiply that by 2 on both the top and the bottom and get 2 over 10. So this fraction is equivalent to 1/5 and 5/25. I can also take 1/5 and multiply, let's do times 8. And that will give me 8 over 40. So as long as we're multiplying and dividing the numerator and denominator by the same number, we can generate really infinitely many equivalent fractions for any starting fraction that we have.